Well, hello there. This is GRC 320. This is Lab 4. Today we're going to go over check sheets or checklists, if you will, standard operating procedures or SOPs, and the concept of Poka Yoke. If you can't measure it, you can't manage it. And I agree with that. I think we have to be able to measure what's going on in our processes in order for us to manage it. So today we're going to go over the total quality tool of the checklist or the check sheet. It's a pretty fundamental tool um, used in many applications for many different purposes. The check sheet is a graphic data collection tool that allows one to collect, compile, and interpret information. So this particular little check sheet, you have a student, student name, and then you have the dates and if they attended or not. Simple check sheet. One of the what we got to do is when we're looking for a check sheet, we got to figure out what are we deciding to measure. Is it going to be a range of measurements? Are there going to be some type and count of defects? Are we going to be actually looking for the causes of the defects or the location of the defects? Or are we looking to just verify that specific steps have occurred? There are two types of data that we can collect. The attribute data, which is something that you can count, otherwise known as discrete data. In this case, the number of rejected folds. It's counted data. You're counting the defects as they occur. Variable data is something that you measure on a continuous scale, like the caliper of paper or of a blanket. So two types of data we got to make sure we can, and this is going to affect us further along. We start looking at control charts and other types of data analysis. We got to figure out what are we actually measuring. Attribute data, things something that we can count, or variable data. And attribute data can also be a yes, no, a binary response. So pass, fail. We decide the types of data to collect and what are the variables. So a variable is in a process that can contribute to the problem. Date, time, the batch, when it was actually made, the machine or the process, the man, the operator shift, environmental, etc. So you can see this mirrors a lot what we did in the cause and effect, the fishbone of those five categories. There are six categories we had in the fishbone. But these are all variables that can affect the process. So we got to decide what check sheet to use. Are we going to use something like this, which is a process distribution check sheet? It gives us a range of measurements. So this is variable data. So you can see here on the bottom, there is the variable data that's being measured, and then this is the frequency of those measurements happening. So this looks just like a bell curve where you have a typical bell-shaped frequency with the center being the mean and then data surrounding the mean. Pretty cool because when it is filled out, it does show you the frequency of the data. So if you've got a unimodal or you've got some kind of kurtosis going, you know you might have some issues, which could be an indicator of fault. This is a plate remake check sheet. So let's just look at this. It's got the date of this occurred. It's got the types of defects that are occurring. So these are plates. These are physical plates on a printing press. And then we have two shifts that are occurring. And then we just count the date so this is all attribute data. So we're counting. There's 8 scratches that happen in shift one, 4 scratches happen in shift 2 for a total of 15. So we can not only can see what defects are occurring in the shift, we can also see the frequency of the defects. So in this case, our plate wear is our number 1 defect. This is a little more complicated in that it's got a key. So the key here, X, O, and then L, indicate 2 types of defects. And then when we have resources, so we've got 2 presses, and then these are all the units of the presses, so it's a 4-color press. And on shift 1 experienced all these defects on that particular unit. Shift 2 had the same somewhat experience. So we can see here we're having issues with the unit 1 on both presses, and relatively similar defects are occurring. So this one's cool because it tells us what defects are occurring, what resource they're occurring, what specific location on the resource they're occurring, when they're happening, and what we could go further is maybe on that shift, figure out what person it's happening to. So you can see the check sheets can get granular as we want to get further into defect and root cause analysis. This is a plate defect location check sheet. Again, we have some the defects here. We got cracked, scratched, bad bends, emulsions, and other. And then here we could do is you can actually locate where those defects occurred on the plate. So you can see here we had a bad bend, it looks like on the lead edge of the plate, and on the print side of the plate where it gets hung, we've got a emulsion. So you can see we have some issues going on here, and it shows us the location of the plate where it's occurring. So check sheets are everywhere. This is a check sheet when you went to the dentist, right? If what we're going to talk about a little bit later is it's called mistake proofing or Poka Yoke. So say if you went to the dentist, they took your notes, and they circled the particular tooth they want to extract. So they know exactly what tooth it is a problem. So they could pull this up 6 months from now and say, okay, that's the bad tooth. And basically it just prevents a problem or a defect from occurring if, say, like if they circled the wrong one, or if they forgot which one tooth you were going to be pulling, then they pull the wrong tooth. That would not be good. We've seen this one quite a bit. Difference between 2 carriers of cell phone. Obviously, the red would be a little bit more better. So we can use this graphically in what we call Maruka, which we'll learn about a little bit later. It's visual. So the check sheets are very visual for us as graphic communication majors. We can utilize them and to make them very interesting using heat maps and such. So it's a very cool tool to use. So how to create a check sheet, and you guys are going to create your own check sheet. Number 1, you identify the questions you need to be answered. You select the types of data that can be used to identify or quantify the answer. So you're going to choose the attribute or the variable. You're going to identify the potential problem areas. You're going to outline the production process variables that are important. You're going to select the type of check sheet based on the type of information sought. So if your check sheet is the production process has a lot of resources, you're going to want to do a check sheet that's specific for resources to locate the defects that are occurring with the resources. If it's not so much, a resource like a pizza oven or something like that, it's more like a person or a shift, then that would have to be what you'd want to measure is the shift, maybe people, and then the types of defects that are occurring in that process. Step 3, you create it. And then you have to write instructions on how to complete the check sheet. Believe it or not, even though how simple check sheets are, just write a real simple how-to instructions on how to complete it. And I want you to do that on your guys' assignment. Step 4, test it. Make sure it works. And then modify it if necessary. And then after that, deploy it and begin data collection. So the data collection would be the proof in the pudding in the control phase, and you're seeing how well that check sheet has been used to correct an error, or to define a process, or to prevent errors from occurring. So to verify the steps in the process have been complete, and then you can use the check sheet as a training aid and a proof of completion. In 1 year, in the U.S., light bulbs caused over 8,000 house fires, resulted in approximately 50 deaths, and light bulb burns resulted in over 12,000 emergency room visits. So what do? How do you change a light bulb? You unplug or turn off the power to lamp. If feasible, let the old bulb cool. Remove old bulb. Check label on lamp for maximum recommended wattage. If the maximum recommended wattage is not indicated on a lamp, on most lamps use a bulb with a maximum 60 watts. Install new bulb, plug in lamp. So obviously this thing is just all run down. You can have these as bullets. So a check sheet doesn't necessarily have to be like a cross off. It's just a linear. In this case, it's a linear process of process steps that are occurring that you do on a linear basis. The benefits: well, it's quick, efficient, it's graphic, it organizes data, it's easy to deploy, and it mistake proofs the process. However, we got to keep in mind there are some biases that can occur. The exclusion bias is that we just miss data or a part of the process in our designing the check sheet, and then this was something that you'd want to find out from the data. Are you getting what you want from the check sheet? If you're not, then there's some kind of an exclusion bias on here that that needs to be dealt with. The interaction, the measurement changes the process itself. So, like if you're testing the air on the tire of your car, in the process of actually testing the air psi, you're actually letting air out. So by testing the process, you're actually affecting the process. Perception, we all have different ways to perceive data collection. We all perceive things differently. So that's something that's a human element that we have to address. This is why we need to have how to use the check sheet. Operational, there's success and failure in following instructions. Can the people follow instructions? So you might have to babysit them for the first couple of times in using the check sheet, which I'll show you in a minute, which we had to do. And then non-response, dismissing data can skew results. So if you're missing the data that you're supposed to collect, you can actually make the process worse, because you'd be going after defects that are not necessarily what's causing the problem. And then approximation or estimation, in lieu of real data, people just guess. One of the things the check sheet does really well is a standard operating procedure. So we've all done this. Maybe your mom or your dad's told you how to clean your room, or your instructor has told you how to fill out a test, or there's some kind of a process that's given to you as like complete these steps. So SOP is a predefined process used to complete a task or resolve a common issue. So it's useful for training, defining repetitive process to eliminate waste. And the purpose of the SOP is to minimize the amount of time and effort it takes to complete a task or solve a problem effectively. And the goal of an SOP is to reduce unintentional friction and to minimize waste in the process. So we saw this unintentional friction and non-value added in our flowcharts we did on the previous lab. So this is check sheet would be a way of us having, dealing with ways to resolve non-value added. One thing about the SOP is that you want to have it drafted in such a way on your check sheet that even though you might have to have like basic instructions on how to use it, that it's relatively graphic and that people can come up and how to use this machine. It's like when you go over and you're using the Konica Minolta in the print lab, if Peter had a check sheet on there, and you follow these steps to download your PDF and to change the print specifications, you wouldn't have to bother him to figure out how to print, so you'd have it right there, simple instructions as far as this is what you do. This is an example of how using non-value added identified in the actual state of a flowchart. So in this particular process, I showed you this flowchart when we were doing flowcharts. So we have identified non-value added major delays in the upstream process of getting a job order from a customer. So this is the upstream, this is the customer, in our interaction with the customer for job intake. So yeah, the assets, and what we call assets are all the documents, the text, the copy if you call it that, photos, any kind of a web link or any kind of information that goes on the job, either print or digital. We call those assets. Now, it might be something if you get from this class, is that if you're a graphic designer, you might want to call assets something, the raw materials coming in from the customer. So we had a relatively high level of a delay here, and the assets were not attached to the job or submitted incorrectly. The assets were not vetted before submitting, which required this extensive feedback loop of edit and approvals. And then at times the job would just get stuck in this edit and approval, and it would never get done. And that affects our cycle time, and we'll talk about that a little bit later. But the cycle time is where we live, and we can't reduce our lead time until our cycle time goes down. We'll talk about that a little bit later. So having a job in limbo is one of the worst things that we can have as far as waste. When we did send the PDF proof, well, the customer, because they didn't supply us the correct assets, see, we're catching these errors occurring way downstream, and then all of this is another feedback loop. Sometimes it has to go all the way back up here, or sometimes it has to go over here. So we had this major non-value added with assets being given and just educating the customer as far as how to submit jobs to our process, because we have two processes. We have a public affairs process, which approves all the text, make sure everything's kosher, language-wise and image-wise, and then you have the graphic design where we are actually doing the work and printing. So what we did is we came up with this customer pre-production checklist. So it tells us logistics: are you the originator? Is your right account is there money in the account? Do you need an estimate? If you're not the correct person to submit this job, then give it to the person who is the person who should be submitting the job, because what happens is that the person who submits the job is the person who we would proof it to, and if we proofed it to the person who doesn't have the power to approve it, then it gets stuck in this limbo on further downstream we were talking about. So we addressed it there. So we created this because customers were not submitting job specifications correctly. They are either missing assets or they're not understanding who their customers are. So they would come up to us, design a flyer. Well, who's this flyer for? Who's your audience? Well, I don't know. You know that. I was like, no, we know. I don't know that. We're designers, right? You need to know who your customers are. So they needed to do a lot more of the, gathering the recipe, if you will, before we started baking the product. So threw it back on them, make them really intentionally think before they come to us, which has resolved quite a bit of the non-value added that you saw in that flow chart. Or they had the wrong account, or they weren't the correct person to submit the job. And then we had a big one here because people were totally clueless as far as what goes into a bulk mail job. I mean, there's so many steps in the bulk mail, and you got to, there's checks being cut to the USPS, there's variable data, there's authentication of the mailing lists. Just quite a bit of information that doesn't even go into design and steps that have to occur. So we did all these, and so these are all linear steps that they would fulfill before they submitted the job to us. And then what we would do for our really problematic customers, we would actually have them turn this into us before they were proceeding to the job, just to make sure we saved a lot of the non-value added on our end. So on the standard operating procedure, check sheet is an externalized, predefined SOP for completing a specific task. It defines a process that has not been formalized. Once the check sheet has been created, it's easier to see how to improve or automate the system so you can improve further. And it eliminates forgetting to handle important steps that can be overlooked. On that note, we're going to be talking about this last concept of the Toyota production system. It's called Poka Yoke. And so this is a check sheet that's using Poka Yoke, which means mistake proofing. You're preventing errors from occurring. And it uses another Toyota production system concept of Maruka, which is visual control or colors, to identify specific attributes or parts of the process. So you can see here on this one, we can actually use Maruka, which is color. It's this particular Poka Yoke check sheet is specifically for preventing defects from occurring. It's not saying, hey, this is the linear process or whatever. It could be, but you're looking at the check sheet under the Poka Yoke to prevent defects from occurring. Okay, so now that we have that, it's a real simple lab activity. I have just a blank PDF that I have on there that you can pull out, or you don't have to use this if you don't want. You can just, you can use another sheet of paper. What I want you to do is come up with a check sheet from your work, from your organizations, from your personal life. I want you to tell me, locate, and you can tell us what defect is occurring. So it's going to be a defect location check sheet. You're going to tell me what type of defect. Are you going to count them? Is it countable defects or is it measurable defects? If it's variable defects, what's the variance of the desired measurement? So what's the sweet spot? 4 hours, 2 hours, 2 inches, such and such, right? So it's measured. And then you're going to give me the verification of order and operation steps. And then you're going to include at least 2 of these variables when you're doing this check sheet. You're going to include date, time, or batch, equipment, operator, shift, or environmental. So you're going to pick 2 of these things to make sure you include this into your check sheet. That is it. Good luck and look forward to your response.